We're going to be creating BPSK and QPSK modulations using Desmos, and we're going to illustrate how they're actually created using a what's called IQ modulation, just like we looked at before in phase and quadrature modulation. We're going to need some data, and here's our data: ones and zeros, a square wave. Well, high level is 1, low level is 0, 1, 0, 1, 0, 1, 0. The amplitude, notice that this is plus 0.78 in the vertical axis and minus 0.78, which is what we need. If you look at the IQ diagrams that they used to represent QPSK in a minute in our notes, they're actually located at that amplitude. So what are we going to do with this? This is our data, ones and zeros. And what we're going to do is let's shift it up just in our visualization. So I'm going to do that using this here and plot it up here in green so that it does interfere what we're going to draw here on the bottom. So we have our data. Now we need a carrier. Here's our carrier. We're going to first pick our quadrature component of the carrier, which is the sine wave or a sine wave. So our goal is to modify this sine wave using this data. So whenever there's a 1, we're going to send a sine wave. And whenever there's a -1, or sorry, a 0, we're going to send the opposite phase. And let's see what that looks like. So I'm going to show you here in orange the BPSK modulation of our carrier. So let me zoom in here. Let me remove our carrier. Well, let's leave it in there. So notice what happens here. So I have our carrier, well, in this case a little bit smaller than our carrier, that doesn't really matter. And notice what I'm doing. I take in the carrier and whenever I switch from a 1 to a 0, instead of keep going up, I start to go down. So I switch my phase here. I'm going up instead of, and with a change of bit, instead of going up, instead of going down, I go up in this case. Okay, so if we zoom out, notice that we have two symbols. Let me remove our carrier and we're going to leave just our modulated signal. So we have two symbols. For a 1, they look like this, and for a 0, they look like that. And notice that whenever there's a 0, you'll see that indeed that's the shape that we're sending. Okay, now we're going to do the same, and we're going to do the same with this waveform right here. So let me turn on our BPSK signal, our green signal, and let me turn on this one right here. This one is also a series of ones and zeros, but it has the duration of the bits a little bit faster, or a little bit shorter, excuse me. That doesn't really matter, but we're going to generate also QPSK with this one. In this case, we're going to modulate our cosine wave here. So if you take our cosine wave, notice that is a cosine wave, and we multiply it by our data, which is plotted right there, 1, 0, 1, 0, 1, 0. Whenever we send a 1, we are going to send a cosine, and whenever we send a 0, we're going to send one that is the opposite phase. So notice that in this case, when this sends a 0, instead of going here, it's going to jump. There's going to be jumps of phases whenever there's a change from 1 to 0, or from 0 to 1. So let's see, let's plot that, and that is this waveform right here. So notice that indeed, let's zoom in, that whenever we send a 1, our modulated signal, the red signal, follows the blue signal. But whenever it's time to switch to a 0, instead of continuing with the same phase, we immediately jump all the way up 180 degrees. And instead of continuing and growing right here, we jump and we continue up there. And that is our, in this case, BPSK modulation for our cosine carrier. So notice what we have done here. Let me put this to. We have modulated our sine wave with BPSK, is this here, with symbols that last a little bit longer. Let me plot both symbols there. So the green symbols modulate the carrier and resulting in the orange waveform right here. And the, let's say, purple or dark purple symbols modulate a cosine wave and resulting in this waveform right there. Now, if we add these two, if we add the orange wave and the red wave or brown wave, we add these two here, let's see what happens. So let me turn this off so that it's not too crowded, and let's add let's plot the addition there. This is a QPSK signal. Let me show you how we're going to read this graph. So what we're doing here is we're using a trick where our green signal, the period of our green signal, is double the period of our purple signal right here. So that gives us the ability to do this, to create any combinations of ones and zeros for 2 bits. So notice that we have 1, 1, 1, 0, 0, 1, and 0, 0. Here are between these levels right here, I'm generating all combinations of possible symbols. Now, our symbols now last a shorter period of time, so they only last here. So whenever I send a 1, 1, I send this symbol right here. That's shown right there. Whenever I send a 1, 0, I send this symbol right here. Whenever I send a 0, 1, I send this symbol right here. And whenever I send a 0, 0, it's the last one, 0, 0, I get this symbol right there. And of course, these are very hard to draw by hand. That's why we use a computer to represent it in time. And in real systems, there's other things that you need to do. Additionally, you need to do something called pulse shaping before you put this over an amplifier and the antenna. But we're not going to look at that here. So quick reminder, let me go back to QPSK here. So remember, in QPSK, we have 4 symbols, 0, 0, 0, 1, 1, 0, 1, 1. And what we have done is we have used Desmos to actually generate those 2 symbols, 0, 0, 0, 1, 1. Let's start here, 0, 0, 0, 1, 1, 0, 1, 1. So here are a combination of all the symbols. And this is what a QPSK signal would look like. So every time that you have a 0, 0, notice that you have this symbol here. So if you go over here, this is a 0, 0. Over here, 0, 0, 0, or low, low, it is a 0, 0. And that is how we actually generate QPSK signals.